here to cover while a few more folks are filtering in and joining us. My name is Mark Egge. I'm the project manager here at High Street for phase 2 of the SunCloud AID grant project, which began more than 5 years ago with an application to FHWA for an accelerated innovation deployment grant to develop a regional data portal. So today is the culmination of a process that's been going on for a long time. And we're really excited to get to share out and to roll out and share this training with you. I'm joined this morning by my co-host, Ted Brown, who's the Transportation Performance Manager at MAG and the project manager for phase 2 of the AID grant. And I think Ted has an announcement to share about in-kind contribution forms.
Thanks, Mark. Yes, if you are attending from a member agency and you are not in a federally funded position, we would really appreciate it if you could fill out an in-kind contribution form to help us towards the project. I will post a link shortly in the chat where you can access that form and download it, and you can return it either to me, or there's a MAG person list at the bottom, or to your MPO representative. Either way would be fantastic, and it would really help us out. So thank you.
Great, thanks, Ted. And this has been a true collaborative effort between the various planning entities that supported the pursuit of the original grant and have participated over phase 1 and now phase 2 of designing, choosing the data layers, choosing performance measures, choosing functionality to deliver and provide through this open data portal. A few housekeeping items before we get going. First, I want to let you know that this presentation is being recorded. It will be hosted on MAG's YouTube page afterwards, so this will be available for posterity. If you have colleagues who weren't able to attend this morning, we'll share the link afterwards and you can refer them to this recording. During the presentation, please keep yourself on mute. If you have questions, you can enter those into the chat box. And there will be an interactive session at the end. Where there'll be an opportunity to have some Q&A and dialogue. So our agenda this morning is as follows. So we'll begin with a review of the data layers that have been produced during phase 2 of this project. Give you an overview of what those data layers are, what they contain, some thoughts about how those might be used in a planning context. Then we'll switch over and look at the analytical tool and talk about, all right, we've got all this data. How do we use this? How do we drill down to the data that's relevant to your agency, to your planning area, and what are the tools that we've developed and provided to surface and make use of this data? And then at the end of our time today, we'll have an interactive exercise, which will be an opportunity for you all to get your hands on with the product and the data. And to ask questions that may arise during the presentation or during your experience pulling data back out of the portal. So we'll go ahead and get started with the discussion of the SunCloud data layer. So the core of this project is putting together a high quality set of data layers that describe the transportation system and transportation performance across the Sun Corridor region, the 5-county region spanning roughly from the Phoenix area to the Tucson metro, covering about 6 million residents. So there's, I wanted to begin by clarifying, what makes the SunCloud different than other existing data resources. There's azmag.gov. Many of the participating entities on this call have their own data portal. So what makes the SunCloud different is a few things. One differentiator is that the layers that are provided through the SunCloud, they all tie back to the foundational GIS work that ADOT has provided through their ADIS linear referencing system line work. And so any of the data layers that are hosted on the SunCloud coincide with the line work from ADOT. And if you want to do your own offline analysis, you can pull those data layers and directly intersect them with any of the data layers that are provided by ADOT from their roads and highways instance. This is hosted on azmag.gov, so an ArcGIS online platform, which means that if you all are ArcGIS users in your respective agencies, you can connect directly into this data, bring it into ArcGIS Pro into your desktop environment, or use the ArcGIS online map viewer and connect to it directly. We've tried to provide unique data sets that perhaps cannot be easily obtained elsewhere. For example, the data set describing broadband quality, or the data set describing the portion of users on roadway facilities that are from disadvantaged areas. We've tried not to compete for clicks with other data sources that exist, though in some cases we have reproduced some existing layers to provide regional geographic coverage and standardization. So many of the data layers that are provided in the Sun Cloud are a result of taking existing data from individual member entities, from MAG, from PAG, from ADOT, from other MPOs, and stitching those together into a cohesive whole that provides a regional view of that data. We've attempted to make this data easy to use, in particular through providing an interactive tool to access and interact with that data, and to bring all these different data layers into one place. So you've got a one-stop shop for all of the data that's available through the platform. One of our primary objectives in developing the data layers has been to support grant applications or other competitive funding opportunities. That'll be a focus of our training today. We've tried to add value through combining and doing some pre-processing and analysis with the data, pre-processing with the data layers to combine together multiple data sets to give you more information than the sum of their parts. For example, with our safety data layers, we've combined both crash counts and AADTs to be able to calculate crash rates. And so we've added value into the data sets that we've provided. The data sets in general are high quality. We've tried to avoid bringing in any attributes or data layers that does not have good coverage across the region. And we've tried to pare it down to just the most interesting attributes. So this is not, these are not the definitive data sources. This is the distillation of many data sources into a single portal that you can access as a one-stop shop for understanding regional transportation performance. So next, I'm going to take us through just a brief description of the data layers that have been produced and are available through the Sun Cloud data portal. So we'll start with our safety data layers. We produce safety data layers that describe safety performance on roadway sections or roadway segments between intersections, and then at intersections or junctions. And keeping with this theme of adding value, we've applied the Highway Safety Manual predictive methodology to the safety performance here. So you have not only crash counts, but we've taken that a step further and applied predictive methodologies to help differentiate or separate out areas that are busy and just have a high exposure factor due to high AADT versus areas that may be unlucky, that had perhaps a spate of crashes that is unrelated to the inherent safety of the facility, from areas that are inherently dangerous. And so we've used the Highway Safety Manual's predictive methodologies and applied that to the crash data to be able to produce a data layer that gives you both what you would expect of a safety layer in terms of counts and rates, but also to help you all from a planning perspective really differentiate and understand where there are safety needs in the region. And so these layers include safety performance function-based prediction of fatal and severe crashes, how many you would expect to see for facilities of a similar roadway setting, and also an empirical Bayes adjusted excess expected crashes, which is kind of that ultimate number that we get to that says, everything else being equal, do we see more crashes or fewer crashes on this facility or at this setting than you would expect, given other roadways in similar settings. We brought in some asset condition layers. We can't talk about regional performance, regional transportation performance without talking about maintaining your assets in a good state of repair. So we've brought in a pavement condition layer, which is a combined pavement condition layer from multiple regional agencies, including data from MAG, Tucson DOT, Pima County DOT, Arizona DOT, and many of the agencies in the area use different pavement condition indices. And so to produce this regional view of pavement condition and to provide apples to apples comparison between regions, we've crosswalked that data to a standardized good, fair, poor standard. And we are currently in the process of complementing or augmenting this data with an additional data source coming from connected vehicles that will provide another standardized regional view of pavement condition. That'll be finalized, I think, later on this month. Additionally, we've brought in information about bridge condition for bridges and culverts. to provide a comprehensive view of asset condition. Primary focus of the data layers in the Sun Cloud is focused on mobility and travel demand, and we've attempted to take a multimodal approach to this. In the phase 1 of this project, there was a regional bikeways layer that was built out. To this, we have added a data layer describing transit ridership. So the data layer identifies all of the regionally operated routes and who operates them, as well as the typical daily ridership. And we've attempted to present that for a standardized date across the region. It varies a little bit from operator to operator, but in general, it's like a typical weekday in fall of 2022. We've brought in a data layer of travel times to help identify which facilities provide reliable travel and which facilities generate travel or delay. And then we've also put quite a bit of effort into producing a regional travel demand layer. So this is based on the travel demand model exports from MAG, PAG, SVMPO, and Arizona DOT. And we've stitched these together. We've scaled the volumes in the layer to a standardized base year of 2019 and a standardized future year of 2050, even though these TDMs have various horizons, and calculated out current volumes and current and future volume capacity ratios. We've also developed a separate layer that shows planned future roadways and the modeled volumes on those roadways. So this provides a regional view of the expectations about where there will be growth and changes in traffic patterns over the next 30 years. We've also brought in 2 data layers describing that's relevant for understanding the freight uses of the regional network. We've brought in a layer with FHWA's designated freight corridors, and then also with assistance from modelers at MAG, processed ATRI GPS data for long-haul freight movements to model out and count the relative number of freight trips occurring on regional roads. So the freight data layer there is not all freight trips, but it is a relative comparison of how many freight trips are being carried by respective roads. Equity has also been an important consideration throughout the development of this project, and the primary data layer that we're excited to include with the data portal here is a layer of disadvantaged facility users, in which we used Replica as a data source to essentially perform a select link analysis for each segment in our Sun Cloud region, each roadway segment, and identify the portion of users on that roadway who have a home location in a designated disadvantaged area. So we can provide an estimate of the portion of users on any given road segment who are from a disadvantaged area. We've also brought in a data layer describing broadband coverage, in hopes that there can be greater alignment between planning for broadband infrastructure along with planning for roadway and transportation infrastructure. This includes estimates of fixed and mobile connection speeds, as well as estimated locations where there may be unserved households who don't have access to broadband internet at all, or underserved households who have access to broadband, but perhaps not broadband that meets modern standards. We also wanted to support your all's agencies in navigating the NEPA process. That was part of the mandate for this grant. And to do that, we've put together a data layer of what we call environmental indicators that identify areas of greater environmental concern or sensitivity. And this is drawing from a number of different environmental indicators, including air quality, habitat, conservation areas, cultural resources, tribal lands, water resources, et cetera. And the layer is a bit unique. Our approach to helping convey the information to you all about where there are environmental indicators that might indicate a higher degree of environmental concern, that might require a higher degree of NEPA assessment to develop a project, was to bring all these data layers, or bring all these different indicators together and include them in a single layer. And there's some intentional overlap with the data layers here that provides kind of a visual representation of where there's a concentration of environmental indicators. So it works a little bit different than how most GIS layers work, but I think once you get the hang of it, because you attended this training webinar today, I think you'll find it to be a useful resource. We've also brought in some additional reference layers that we had access to that are often called upon from a transportation planning standpoint. We brought in a copy of the MS2 traffic counts from Arizona DOT. That includes the raw traffic counts at both automatic traffic recorder and short-term count sites dating back to 2010. And then we have links back to ADOT's MS2 site. So if you want to get the full data behind a particular traffic count station, you can begin at the SunCloud Explorer and link back to ADOT's MS2 instance. We've also brought in the climate and economic justice planning layer indicating disadvantaged areas and provide the ability to filter that down to just areas that are designated as transportation disadvantaged. Along with the travel demand model, we also brought in the regional transportation analysis zone geographies. That includes counts of households, population, and employment by TAS for our 2019 base year and the 2050 future year, and also brought in a collection of major planned projects from the respective regional long-range transportation plans, so you can see where there's planned investments in the region. And this is all in addition to the data layers that were produced during phase one of the project. So phase one of the project produced data layers pertaining to land use, to housing, recreation, bikeways, as I mentioned. And so those data layers are also available through the data portal. So let's go ahead and take a look at these data layers. So we've produced these data layers, and then the data layers are displayed through this application we call the SunCloud Explorer that brings all these data layers together in one place and provides different ways to view and symbolize that data, as well as to filter down, export the data, and support your analysis uses that we'll talk about later on in our presentation this morning. You can access this yourself at suncloud.azgo.az.gov. There will be a link to this tool prominently on the SunCloud data portal page. That's one of kind of our final wrap-up items. So that's coming soon. In the meantime, you can follow along today by typing in this URL into your browser bar, and perhaps Ted will be kind enough to put this link in the chat box as well. So I'm going to switch windows here. So before we get into the data layers themselves, I did just want to provide a brief overview or brief introduction to the SunCloud Explorer interface here. So this is the application that we've developed to enable the SunCloud users to quickly and easily access the data layers that we've produced through this project. So just kind of moving in counterclockwise direction here. The primary controls for this application are here on the left-hand side. There's 3 tabs. There's a layer list tab that you can use to change which layer is visible on the map or layers. There's a filters tab that can be used to select and zoom in on a specific region, or to filter down which features are displayed on the map based on attributes of those features. And then there's a scoring tab, which we'll talk a little bit more about later this morning, where we have taken these data layers and taken a performance-based approach to using the underlying data to understand regional performance and where there are investment needs. Within the interface itself, it's a mobile responsive interface, so you should be able to use this on your phone. You should be able to use it on your tablet, and if you want to, you can hide the sidebar entirely. Here within the map, there's a control to be able to change the base map. So if you find that the layer that you're visualizing or layers you're visualizing displays better on a dark canvas, you can change to dark. If you want to display that on satellite imagery or aerial imagery, that's available as well. We've attempted to optimize the display of all of our data layers to work on either a light or dark background, but you can control that as you see fit or appropriate. There's a print button here, which I'll show a bit later, but that allows you to print a display map of what's currently displayed on screen. And then finally, there's a table view widget that allows you to view the attributes of the data layers that are displayed on the map, for example, bridge condition. You can interact. You can go from the table to the map if you wanted to, for example, zoom to a specific feature on the map. But the most important thing that's provided through the table view is the ability to export out the data. So if you want to export this data out and bring it into your own analytical environment, the way that you do so is through the table view. Choose the table that you want, and then you can export this data out to a GeoJSON format. So the layer list here provides a list of all of the layers that we've assembled into the Sun Cloud Explorer. So these are all the layers that I just described, and it's put together in a manner here that that controls the visibility of the layers as you click on the cards corresponding to the layers, and also allows you to control how those layers are symbolized. One very important feature that we've built in here is an information link. So for each of these data layers, the data layer itself is hosted on AZGeo on the SunCloud data portal. And behind the layer here is full metadata about how the data was produced, what the data sources are, what processing was performed about it. So here's our junctions safety layer. There's detailed information in here about the manner in which this data was prepared. There's also a credits attribution on each of these data layers that will describe where it is that the data source came from. So just moving down the list here. The first data layers that I mentioned, we have our safety data layers, and let's zoom into the Tucson region. I lived in Phoenix for a number of years, but I'll try not to be overly Phoenix centric today. The default symbology here is showing excess expected high severity crashes. And so what you see on the map here is symbolized areas where there is either moderate potential for crash reduction, meaning that the number of observed crashes is roughly within range of what you would expect given the statistical expectation of crashes. And you also see some blue areas here that indicate that actually the performance is better than what you would expect given the statistical expectation. The widget here allows you to change which attribute is symbolized on the map. So each of these data layers has multiple attributes of interest. And so if you are interested in seeing where perhaps there's been bicyclist and pedestrian fatal and severe injuries, you can change the symbology to bicycle and pedestrian injuries and see that the legend is updated here. And in the downtown Tucson area, it looks like there haven't been too many in the downtown area, but it does look like there's been 2 here on Oracle Road. So when you have data layers displayed on the map, if there's a particular feature of interest, you can click on that feature, as I've done here, and that'll bring up a pop-up box. And that pop-up box will display all of the information for the visible feature. And depending on the size of the box, sometimes it's useful to dock the pop-up box over here on the right, so you can see more of these attributes. So here you can see all of the various attributes that are available within this safety data layer, including the number of non-motorized fatal and injury crashes, which is 2. We've also included a level of safety service data layer that again takes a predictive approach to understanding or to describing where the performance, the safety performance of a roadway setting relative to a statistical expectation. The roadway segments layer is much the same as the junctions layer. It's the same set of attributes, but this is calculated for roadway segments. So instead of having rates based on the number of entering vehicles, it's based on per 100 million VMT. In general, with the symbology that we've applied and tried to be consistent with across all the different layers, brighter colors correspond to more extreme values. So the orange here corresponds to an elevated fatal and serious injury rate. As I mentioned, bridge condition layer. This gives you just a high-level good, fair, poor rating based on the bridge's structural evaluation rating. We've also brought in a bridge deck geometry evaluation rating, which just describes like is the bridge deck adequately wide for current traffic or for future expansion. And this does include both bridges and culverts. And if you want to see which is which, there's a type symbology here. And you can see that there's a mix of bridges and culverts here in the downtown Tucson area. Our pavement condition layer is it's very simple. It describes it breaks up the network into to segments and ascribes to those segments a condition rating of good, fair, and poor. And what's unique about this data layer is that it is a standardized and combined data layer that allows you to have an apples-to-apples comparison between pavement condition in the Sierra Vista area or in the Peoria area. You get it all here at a glance. The transit ridership layer shows both the routes themselves as well as the estimated ridership. So in this instance, we can see that the SunTrans streetcar has an estimated average daily ridership of 4,270 people. And there's a few different ways you can symbolize that. The travel demand layer, as I mentioned, is stitched together from the combined outputs of multiple regional travel demand models, and those have been standardized and combined to provide a regional view of travel demand. So that includes travel demand for 2019, our base year, as well as estimated volumes for 2050. I'll note that there is also in here a layer of planned future roadways. And if you're looking at travel demand, you may find it useful to be able to see both travel demand and planned future roadways at the same time. By default, our layer list only displays one layer at a time because most of these layers are they're lines and they would be overlapping. But if you do wish to be able to see multiple layers at the same time, you can just change the display mode to multiple. And now we can turn on our travel demand layer as well as our planned future roadways layer and view the travel demand in the Casa Grande area in the context of planned future roadways. So travel demand includes current volumes, estimated 2050 volumes, as well as volume capacity ratios, a little bit more relevant metric of, do the roadways have adequate capacity? And you can do a quick comparison between current volume capacity ratios and 2050 volume capacity ratios. If you want, you can also see the forecasted volume capacity ratios on the planned future roadways. The travel time layers displays the level of travel time reliability metric as defined by FHWA. It's one of the National Transportation Performance Measure TPM performance measures describing the reliability of roadways, as well as minutes of daily delay. Go back to displaying one at a time. The freight flows layer, as I mentioned, is based on assigned freight flows from ATRI GPS data. So this is collecting actual movements of freight trucks. It's probably biased towards long haul freight movements. But if you want to see, what are the major corridors for long haul freight movements in the region, the freight flows layer shows that. The freight routes layer just shows where there are designated critical rural freight corridors and critical urban freight corridors, which is fairly self-explanatory. The disadvantaged facility users is one of the new and unique data layers that we're providing through the SunCloud that I think that you all will find very useful from a grant application standpoint, as well as just a broader standpoint of incorporating equity into your planning considerations. This may be one of the layers that displays a little bit better on a dark canvas, so I'm going to switch that over here. And the way this is symbolized, it shows the portion of users that are from disadvantaged areas. Again, brighter colors correspond to more extreme values. Thicker lines correspond to more trips. So on this particular section of Valencia Road, it's estimated that it carries 123,000 people daily. And that 81% of those have a home location in a disadvantaged area. And if you're curious where those disadvantaged areas are, we have included the Justice 40 or CEJST data layer of designated disadvantaged areas. So if you wanted to see these two in context, you can go to multiple and turn on the disadvantaged areas, and you can infer that many of the trips that are occurring on this section of Valencia Road are by users who have a home location in one of these areas. The broadband coverage layer is also a unique and new layer that's provided through the SunCloud. We have obtained broadband speed data from Ookla, and which is a speed test provider, and have aggregated up those results of those speed tests to these hexagonal geographies that you see here on the map. Light blue and dark blue correspond to good high-speed broadband internet. And the salmon and red colors correspond to either underserved or unserved locations where we have speed test results. And then there's a lot of areas, all the light gray areas correspond to places where people live, but we don't have any records of speed test results. If you want to, we've also produced a different visualization here, a symbology that shows households without broadband internet. So we've taken census data and assigned a number of households to each of these hexagonal bins. And then we're showing here on the map the hexagonal bins where, according to the speed test data that we have, there may not be existing broadband internet. So in this case, the fixed connection download speed for this area is averages, or the 80th percentile speed test result there was 18.8 megabits per second, which is below FCC's designation of what constitutes a broadband internet connection. And there's 100 households in this area, or 266 people. Okay, switching back to a light gray canvas here. I mentioned that we do have traffic counts. This just shows the site locations and the agency who's collected them. If you click on one of the traffic counts, you'll see that there is a link to the MS2 viewer here down at the bottom. So if you want to see the full details behind the count site, you can click on the link. Otherwise, it looks like we've chosen only to include the raw counts, not the grown counts or the adjusted counts. So these are just raw counts, which is why there's some gaps in years here, because this looks like this site only gets counted once every 3 years. All right, so onto our environmental indicators layer. So this, as I mentioned, the way that this layer works is a little bit different than all of the other layers in the platform. We've intentionally overlapped these different environmental indicator layers, so you can look at this visually and instantly get a sense for where there may be areas of elevated environmental concern, or where there may be overlapping environmental concerns. And so if we click on one of these areas that has a darker shade to it, you'll see that in the pop-up box here, this is says it's 1 of 5 results. And so we can scroll through these results here using the arrows. So we can see that the first environmental indicator here is a critical habitat indicator for the Sky Islands uplands area. There's also a designated grassland area that's been designated as a critical habitat by the Nature Conservancy. This is part of the Coronado National Forest. It is within an area that is in air quality non-attainment for carbon monoxide, and is also within the Upper Santa Cruz sole source aquifer water resource region. So it works a little bit differently with this layer. Again, you have to click on it and then scroll through the different layers. You can see the kind of extent of these overlapping layers, but we think that this provides a good way to understand, or if you just want to get an immediate sense for, if you're planning a project within a given area, is it going to be a straightforward NEPA process? Might you be able to get away with a categorical exclusion versus is it going to require a higher level analysis? We hope that this data layer will help kind of immediately communicate the likely environmental or the likely degree of assessment, or give you some sense for whether or not that's going to require an extended assessment. Traffic analysis zones are included here. You can see, for example, a comparison of current population versus forecasted population in 2050. We did bring in the bikeways layer from phase 1 of this project. So if you want to see where there are existing bikeways, where there might be opportunity for mode shift through better multimodal services, that's shown here. And then we also did bring in a data layer of the long-range transportation plan projects, both intersection or like point projects, spot improvements, as well as linear projects. Those are categorized as you see there. So if you want to understand, where there's existing needs with respect to planned investments, you can do so by turning on these layers. And the last layer here just is the underlying line work that all of the other layers are conflated to. Again, that's based on ATIS. The last thing that I'll mention, all of these data layers, so you can access them here through the SunCloud Explorer. You can click on the information link to go to the portal item. If you are an ArcGIS user and you want to bring this into your offline analytical environment, you can do so by copying the URL to the feature service, or you can export it using the table view. The other way that you can access all of these data layers is on the is through the hub site itself. So under maps and data, and it's not we haven't updated it yet, but in the coming days, you will see here under the SunCloud feature data, not only the phase 1 data layers, but all of the data layers that I just described. There's links to that from here. As well as a search bar. So if there's a particular attribute that you want to search for, you can search for it from the maps and data page. So those are our data layers. So next, so we have all this data, right? And we're describing lots of different aspects of the transportation system. What do we do with all of this data? Well, we've developed tooling to support you all and other users in your agency in kind of drilling down and identifying the data layers that may be relevant to your analysis, to the grant application that you're working on, so on and so forth. And so the general tools that we've provided the ability to symbolize multiple attributes. You've seen that already. We've provided the ability to filter down the layer or the data that's being displayed on the map, either by the attributes of that data or by the geography where that data is located. You can then export that data out for offline analysis, whether that's in ArcGIS Pro or QGIS or whatever geographic information system that you want to use. We've also provided the ability to print a display map of the information that you see displayed on a map, so you can convey that back to your stakeholders or share the information that you've identified through the SunCloud Explorer. I've mentioned already that there are two ways that you can access this data and bring it into your own analytical environment if you want to do some offline analysis beyond what's available in the SunCloud Explorer. The first is direct access from ArcGIS Online by clicking on the information icon to go to the portal item and then scrolling down to the URL for the hosted feature layer, and you can use that to add it directly to ArcGIS Pro. Or you bring it into to Python or R or whatever analytical environment that you prefer. Or you can export the data out in a GeoJSON format, which is a standardized open source data format for spatial data, which you can open in any GIS tool of your choice. So to show you how you can use the filters that are available in the application, as well as the ability to control layer symbology to drill in on specific data elements, I'd like to introduce a demonstration scenario. So in this demonstration scenario, we will pretend that we're a planner within Santa Cruz County, and we would like to help prepare for a BEAD program grant application a year from now to help bring broadband to unserved or underserved locations. And in particular, we'll pretend for the purposes of this demonstration that we are interested in identifying locations that have households with unserved or underserved broadband. We're interested in identifying where that may overlap with disadvantaged population areas or disadvantaged facility users. And we're interested in poor asset condition, kind of on the hypothesis that perhaps we could combine multiple funding sources, bring in some BEAD funding to help pay for a project, and at the same time address existing asset condition needs. So let's go ahead and switch over to the SunCloud Explorer, and we'll go through a process to filter down to some relevant data points. We can print the map, and we can export the data out for offline analysis. So here within the SunCloud Explorer, I'm going to go ahead and turn on some of the layers that are of interest to us. So we're interested in asset conditions. We'll turn on a bridge condition and our pavement condition layers. And because equity is an important component of the BEAD program, we'll want to perhaps be aware of where there are disadvantaged areas. And then finally, broadband is the real focus of the BEAD program. And so we'll want to identify where there may be households without broadband. And I said that we would perform this analysis from the perspective of Santa Cruz County. And so here under the filters tab, we have the ability to filter by location or to zoom by location. And there's a number of different geographies that are built into the tool here to be able to zoom in. In this case, we're interested in zooming into county boundaries. So we can choose county and Santa Cruz County. And this is going to zoom us in on the map to Santa Cruz County. And from this view, it has also applied a filter to the data layers that are being displayed here, and we can see the line work and points corresponding to the data layers that we have turned on. So general, looking at this, you can make a assessment that that there are a few designated disadvantaged areas here in the Nogales area. In general, the roadway condition is fair or poor throughout the area, but there is some sections of poor pavement condition here, again, in the Nogales area. And bridge condition is kind of middling. If this was a view that we liked and wanted to be able to share outside of our organization, we can use the print map widget to do that, and we can call this, let's call this bead program. So for the print icon here, there are a few advanced options here to control the extent and to add some additional information to the map. For example, we can include a north arrow. And then when you click the print button, nothing happens, or it looks like nothing happens. What's actually happening is that the map is being generated here in the background, and it takes maybe 30 seconds for the map to print, and this will generate a PDF or a JPEG image that you can take and print off on your local printer or share in a PowerPoint presentation that shows the data layers that are currently visible on the map. I will mention that there is what seems to be a bug with our printing printing here, that the legend doesn't get pulled through into the printed view for whatever reason. That appears to be a bug with Esri software. So I'm hopeful that that'll get resolved in the future with a future release of ArcGIS Online. But here's the print view of what we're displaying on screen. So let's go ahead. So we're seeing all the information on here, and this may be a little bit more than we're really interested in. I think that what we're interested in is poor infrastructure condition. So we can turn on this filter. We're filtering by attributes, and we can filter to bridges where the lowest condition rating for one of the elements is between 1 and 5. And pavement condition, let's go ahead and filter this down, and let's remove the good condition pavement from our map. And then with our broadband layer, we can filter this down. Let's filter this down to those to just the cells where there's at least one household without broadband. And we know where these justice for disadvantaged areas are. I'm just going to go ahead and turn that off. And so what we're left with here on screen is the features that correspond to the attributes that we've filtered down to, and we can see that there's some poor pavement condition that is in proximity to a concentration of households without high-speed internet, and also proximate to some bridges that are in fair but not great condition. Lastly, if we did want to export some of this data out for our own offline analysis, we could do that from the table view. In this case, we might be interested in the broadband coverage polygons. We can open this up and export out a GeoJSON file, and that's basically going to take all of the broadband coverage data and export that out into a GeoJSON to your JSON file, where I believe that actually will respect the currently applied filters. So you're just getting the filtered data. One thing that I will note, when it comes to filtering by location or filtering by attributes, unfortunately, that is a either or proposition, just due to some awkwardness of how the things are assembled on the back end. If you filter by location, that'll override your attribute filters, or if you filter by attributes, that'll override your location filter. That's just a limitation of the system. And I could have hit this to reset and turn off all those filters. So that is a quick demonstration of how you can use the filtering functionality that's built into the SunCloud Explorer to drill down to specific data elements of interest. Uh, But we'd like to go, or we can go beyond that. We can go beyond just the kind of high level description of attributes in those data layers to really dig into this concept of system performance. And so to do so, we've brought in some of the principles of performance-based planning and performance-based needs assessment and built that into the SunCloud Explorer. And so that begins with defining a series of performance measures. And so with the assistance of the technical advisory group for the SunCloud project, we defined a series of 15 performance measures here describing performance with respect to safety, asset condition, mobility, travel demand, and equity and economic performance. And we use the data layers that are built into the SunCloud to be able to calculate out these performance measures. The way that this is implemented, I apologize, there's a lot of text on this slide. This is mostly included for the sake of reference, but on a segment by segment data or segment by segment basis, you take a given segment, you identify the performance measure that you want to calculate, you query the underlying data layers that are necessary to calculate that performance measure, you run the calculation and you save that for the segment. And then that data gets normalized. You'll see in this next section, we'll talk some about normalized data. And what that means is that we're just converting that data from whatever its units are. For example, it could be a count of crashes, 32 crashes, into a standardized 0 to 100 scale that allows us to compare between different performance measures. And that normalization basically just takes the full scale or range of scores across the network, and it says the minimum score is 0 and the maximum score is 100, and everything in between is proportionally assigned. And then once we've calculated out each of the performance scores and normalized them, then we can combine these together into a composite score by applying weights to those normalized scores. So of course, each of your agencies is working in pursuit of achieving multiple goals related to safety, state of good repair, economic development, et cetera. And sometimes those are complementary in the investment choices that you make, and sometimes those compete for the same limited pool of money. And so weighting is how we represent those trade-offs between competing goal areas in the scoring implementation. So we do that for each of the criteria. We sum that up, and that produces a composite score for the segment. And then we bring in our equity consideration. And so the way in which we do that is you arrive at a composite score that says the composite needs for the segment is 50. And then we apply a multiplier based on the portion of users on that roadway segment who are from disadvantaged areas. And so if you had a score of 50 and 50% of the users on that segment were from a disadvantaged area, that would get scaled up to a composite score of 75 for the segment. That's optional. If you want to turn off that equity weighting, there is functionality to do so, but we think it's important, and we think it's a good way to account for that question of not just where are their needs on the system, but who experiences those needs, to account for that right in our performance-based approach to understanding regional needs. As I mentioned, we use weighting to represent the trade-offs that are made by your agencies between multiple competing goal areas. These are the default weights that are built into the system. You can see that that safety gets the slight advantage in terms of overall weight. These are the default weights that go into the default performance scores. We'll talk a little bit later about how you can adjust these weights to tailor the performance scores in the SunCloud to the own priorities within your respective organizations. So we take this process and we can apply it to every single segment across the region and produce a scored network. And so each segment, there's about, when we take all of the roadways in the region, and these are arterial roadways, these are freeways and highways, and in the metro areas outside of Phoenix and Tucson, or in the incorporated areas outside of Phoenix and Tucson, we've also included some major collectors. We apply this process. It's about 7,700 segments, and each of the 15 performance measures gets calculated for each of the 7,700 segments. That produces a score. We add our equity multiplier to that, and that produces a score network that looks like what you see here on the map. So that's the composite score. If you want to drill down into a sub area, for example, asset condition, we have taken subsets of those measures and calculated them, with respect to asset condition, mobility needs, economic development needs, or safety needs. Or you can also visualize any of the individual performance measures that go into that composite need. So that gives you a network screening, understanding where there's needs on individual segments. But if you want to understand how that adds up to an overall score for the region, you can do that with the dashboard that's built in the SunCloud. And I'll show you this in a minute, but the dashboard provides just a high-level summary of the scores for the segments that are within a particular region. So let's go ahead and take a look at the scored network and the dashboard. So the scored network is it's presented here right front and center. You can turn on the SunCloud performance scores. If you want more information about how these scores are calculated, you can click on the information link. This is the same diagram that you just saw on the slide there. It shows all of the underlying data layers and a description of how those performance measures are calculated. As with our other data layers, brighter colors correspond to areas with elevated needs. So, for example, in the Phoenix area, you can see that there are elevated investment needs in perhaps the older parts of town and kind of the central Phoenix area, and in some of the newer parts of town, Chandler, Gilbert area, where the roads are newer, or where there's less travel demand of those roadways. In many cases, the investment needs, according to this performance assessment, are lower. So this is the combined needs score with the equity multiplier. If you are interested in seeing just the raw scores, you can turn on the unweighted combined score. And see how that might change the scoring for particular roadways. I'm going to switch back to a dark canvas just so we get a little bit more pop here. And you can see the comparison that when we turn on that equity multiplier, that these needs that exist on the roadways that are serving a high proportion of disadvantaged users just get elevated. They get a little bit they are given more preference. For example, this section of I-19 has a combined score of 70.65, whereas which is reflective of the fact that 87% of the users on this roadway are from disadvantaged areas, and without that, the composite needs score here would be 37. I am pointing out here that when you click on a segment, you do get this this pop-up here, and it shows you the individual scores for each of the performance measures for the individual segment in question. So you can drill down into to great detail. And if you want to see the performance scoring for any of the individual measures, for example, maybe the portion of pavement that is in poor condition, you can turn on any of the individual scores from the layer list view here. So that provides a very detailed network screening, the ability to drill into specific segments. If you want to understand what that means in terms of a broader context, sorry, I did that a little bit quick. On the scoring tab here, there's a link to our needs dashboard. So what the needs dashboard does is it takes all of the individual scored segments and it aggregates them up into to composites for the region. And the dashboard is set up in a way to facilitate drilling down to specific areas. When you drill down to a specific area, it filters the selected features down to just those that overlap with the area in question, and then it gives you these roll-up scores. So the combined needs score, the average of all of the segments that are in Santa Cruz County, is a 28.8 needs score. And then you can see the sub area scores here. So if we wanted to understand, what's behind this asset condition needs score, 13.5 combined average, you can see that 12.4% of the pavements in the region are in poor condition. The bridge structural rating for this area is 6.5 on average, deck geometry rating 6.2 on average. And the same thing applies for the other cards here for the other goal areas. And this provides both a high-level summary that you could just take this dashboard and bring it back to your policy advisory committee, bring it back to your stakeholders, and say, here's a high-level roll-up of how our region is doing. If you want to be able to compare your region, your specific county versus the overall area, you can say, hey, we're in Santa Cruz County. The percent of pavement that's poor in our county is higher than the 5-county region, or if you like to benchmark against other counties in the region. For example, you could compare between Cochise County and Santa Cruz County and see that in Cochise County, the portion of pavement in poor condition is a little bit lower than the portion of pavement that's in poor condition in Santa Cruz County. We've also included filters by metropolitan planning organization. I need to turn that off so you can see the list of all of the MPOs. If you wanted to compare between MPOs, that's an option. And we've also included in this metropolitan planning area boundaries. Finally, down here in the bottom right are all of the contributing scores. These are the normalized scores. So from a 0 to 100 scale, if you want to see the raw scores behind there, you can scroll through and see the summation of those scores. So the sum of total delay in the Sierra Vista MPO planning area is 2,900 minutes, and you could compare that versus like the Sun Corridor region, in which daily delay is about 8,000 minutes. So the performance scores layer provides network screening, very detailed information on a road segment by road segment basis of the assigned needs scores. And then the dashboard provides kind of a high level roll up and summation of overall needs within a region. But we recognize that the weights that we have built into the platform by default, they're based on representative weights that have been established by by MAG and other agencies that we've worked with, but they may not match your weights. And so we have further extended this scoring functionality in the SunCloud to allow you all as the users to adjust the weights to match local priorities. Or if you want to drill in and identify a specific subset of needs, you can do that from the scoring widget. So in this case, if we can go back to our bead program scenario, we could use the scoring functionality that's built into the SunCloud Explorer to, instead of kind of looking and visually assessing where there may be households that are unserved or underserved by broadband, we could instead use the need scoring to drill in and use the performance measures that we've defined to drill into a subset of roadways. So let's switch over and do that. So the custom weighting here is provided through under the scoring panel, and it allows you to adjust the performance measure weights. And so let's pretend that we want to identify the bead program criteria that I just mentioned. So we can take there's 15 performance measures in here, and we can just take the ones that we're not interested in and drag the slider over to the left. And then I'm going to hit the lock so that as I'm adjusting these other sliders, it doesn't push this back up. So I'm going to take all of our safety measures and I'm going to zero those out because that's not of consideration for us. We are interested in the pavement and the asset conditions, so I'm just going to leave those on, and you'll see that as I take these other measures and zero them out, it reassigns those weights to the ones that haven't been turned off. So we'll turn off our mobility measures here. Maybe we'll leave on the forecasted change in BMT just to give some consideration to where there may be more travel demand in the future. We'll turn off our freight measure here. And so that pumps up the weight on all of these other measures a little bit higher. And let's just go ahead and give a little bit more weight to households without broadband. We'll increase that to 25%. So now we have a new set of weights. To operate the scoring engine here, click the rescore button. And that will go through and calculate new scores for the region. I'm going to turn off that underlying layer so we'll just see our own layer. And if we zoom back to our Santa Cruz region, we can, this will identify roadways for us that scores higher based on these criteria that we've set. This does include that equity multiplier by default. If you wanted to turn that off under field selection, there's a composite score and a composite score unweighted. If you choose the unweighted score, that turns off the equity multiplier. Turn composite score back on. You can see that that determination with respect to providing that multiplier for disadvantaged facility users. And you may wish to visualize this differently. By default, it just breaks things out into 5 quantiles, but we could instead visualize this by equal interval and increase our class count here to really drill in on the roadways that stand out in terms of the performance measures that we've selected. So in this case, State Road 289 has a high aggregated score. More than half of the pavements on this road are in poor condition. And there's an estimated 42 households without broadband along this road. So this is a different approach to performing a similar sort of analysis in which we're using the scoring that's built into the SunCloud Explorer here to identify where there may be specific needs. In this case, needs with respect to broadband and asset condition.